All right, so we are starting Unit 8, which has to do with modeling trigonometric functions. We're going to focus our attention on the sine and the cosine function. Towards the end, we'll address tangent a little bit, and then for the last unit section, we'll cover modeling and really what it's used for. Okay, so we've talked about functions all year long. We've talked about the linear function when you were in Algebra 1. Okay, we talked about the quadratic function. We talked about cubic functions. We talked about polynomial functions. Okay, rational functions. So we've looked at different function models throughout the course of the year, and that's essentially what the theme of Algebra 2 is. In our last unit, we're going to talk about a function called a periodic function. And a periodic function is a function that repeats a pattern over the same interval. Okay, so we are looking for repeating patterns. Okay, and the period is the time or the number of units it takes to complete one's full cycle. To complete one full cycle of the pattern. Okay, so in a given period of time, how long does it take to complete a one full cycle of the pattern? You can think of this almost like our calendar year. In January, it's our coldest, then it gets to be warmer, and then it gets to be hot in the summer, and then it gets to be colder a little in the fall, and then in the winter, it gets to be its coldest again, and January is roughly the same temperature as it was the year before. And then we start that pattern again. Okay, so think period is like a calendar versus temperature. Okay, the time is 12 months, and we're comparing the different temperatures over the course of a year. So it's cyclical, or it repeats the pattern over a given interval. Our interval is always 12 months. The amplitude is what is known as half the distance between maximum and minimum values. Okay, the amplitude is going to be a really important value in our functions. We're going to use A to describe it. But basically, we're talking about how much do I go up and how much do I go down. And so that number is going to be the same. Whatever number we travel up, we're also going to travel the same number down. And then the midline is y equals some number where it is the halfway point. Oops, halfway point. Horizontally between the maximum and the minimum. Okay, so this midline and amplitude are going to have to do a lot with each other. Horizontal between max and min. Oops, between maximum and minimum. Okay, So I'll describe what that means a little bit when we look at the functions of sine and cosine. But here we go. First of all, you need to decide if the function is periodic. If it does, give its period, its amplitude, in the equation of its midline. All right, so here in number 1, first of all, is it's periodic. Do you notice a repeating pattern? And if you do, then it would be considered a periodic function. And so in this case, we go up and then down and up and down and up, and it's going to continue. Notice how those arrows, and I have arrows going this direction. The maximum is always the same. So we always get to a maximum value of 2. So again, I come to that same max. And I also come to the same min, the same minimum of -2. So the graph never goes below that value. So because I have a repeating up, down, up kind of pattern, this is, yes, it's periodic. Okay? So then if it's periodic, give its amplitude and the equation of the midline. So the midline is halfway between the maximum and the minimum. Well, if the maximum is 2 and the minimum is -2, halfway between -2, so we can even the equation of the midline is equal to add the maximum plus the minimum and divide it by 2. Max plus min and divide it by 2. And so we get 2 plus -2 divided by 2 is 0. So y equals 0 is the equation of my midline, or the x-axis is my midline. And the amplitude is the number that I go up or down from the midline to the maximum and the minimum. So in this case, from the midline, I go up 2 units, or also I travel down 2 units. The amplitude is always going to be a positive value. So my amplitude in this case is the absolute value of 2, which is equal to the absolute value of -2, which is just 2. So my A value is equal to 2. Okay, so I have my amplitude. I also have my midline. Okay, so in number 2, if I'm looking at this particular function, do I have a repeating pattern? So it goes up and then down and then up and then down. So we're going up and down and up and down and up and down. But if you notice, the pattern is not the same. The up and down doesn't go to the same max and the same min every single time. So because we have differing maxes and mins, this is not periodic. So the periodic, it has to be the exact same repeating pattern. Okay, so if you look at number 3, we go up and down and up and down, and it has the same max and the same min. So this is periodic. The midline is halfway between the maximum and the min. So what is the y value that it seems to balance on? And that is this line right here. Notice how this is y equals 1 and this is y equals 2. So y equals 1.5. So 1.5 is my midline. And then the amplitude is the distance from the midline up or down. Usually we're going to go up, okay, just because we know it has to be positive. So in this case, because from here to here, that's traveling a half a unit, my A value is 0.5. Okay? In number 4, as we move, so this is a little bit different in the sense that it looks like, all right, on the left side, we have this kind of up and down, up and down, up and down. And on the right side, it's mirrored. So a mirror image, is that a repeating pattern? And the answer is no. This is not periodic. It is not a repeating pattern from left to right. Okay, so from left to right, as I travel, I'm going down and up and 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 down and up. But each maximum is not the same as it was before. Okay, this is not the same pattern. We can't go from large to smaller to smaller to smaller to smaller to larger to larger to larger. That's not how it works. Okay, so if we look at these 4, 1 and 3 were periodic, but 2 and 4 were not. Okay, all right. So now to conclude, we're going to look at what the function of sine looks like. And so our parent function is known as y equals sine x. If you remember from our work on the unit circle, the sine value was y. So if I had my unit circle going around, I'm looking at the y value at each one of these points. I don't know why I'm writing so small. So this would be, I'm sorry, I wrote that wrong. This would be 1, 0. This is 0, 1. This is going to be negative 1, 0. And this is going to be 0, negative 1. Now we're going to work in radians. So if I look at the sine value is the y coordinate. So we're going to focus on the y values. Notice how at 0 degrees, the y value or the sine is 0. At 90 degrees, the y value is 1. At 180, it's 0. At 270, it's negative 1. At 360, we're back to 0. And if we were to continue going other degree measures, we would also have those same 0, 1, 0, negative 1. Well, we are going to focus on radians, okay? So what we're going to notice is it takes me from 0 to 2 pi to get back to where I started. That is a periodic function. So if I start at an x value of 0, in this case, our x or our input is going to be in radians. So we're actually comparing the y-axis to the degree measure, or the measure of the angle. On the x-axis. So we're not using, x is referring to the angle measurement, not the actual x coordinate. So for the x, we're talking about 0 radians. So this is in radians. Radians. Okay, and this is the ordered pair. So at 0 radians, the ordered pair was 0. At the next key point was pi over 2 radians, half pi, we're at a y value of 1. If I look at the next one, which is pi radians, so pi is over here, we're at 0 again. Then I come to 3 pi over 2, and I'm at negative 1. And then at 2 pi, 1 full rotation, my y value is 0. So for the parent function, I'm going to start with 0 here, 0, 0. In this case, I'm going up 1 and down 1. 2 pi is where my period ends. Okay, so 1 full rotation is 2 pi. So what's halfway in between is pi. What's halfway in between 0 and pi? Halfway in between 0 and pi is pi over 2. Halfway in between pi and 2 pi is 3 pi over 2. You're going to notice that we do the same process for almost all of our graphs, where I want 5 key points to graph a function. In this case, for sine, 0, 0. Then I go at pi over 2, I'm up to 1. At pi, I'm back to 0. At 3 pi over 2, I'm at negative 1. And at 2 pi, I'm back to 0. Because this is a circle, there are also other angles in between. And so what's going to happen is I'm going to connect this. Whoops, that's not what I wanted to do. I'm going to connect this curve, and it has to be a curved. Think circular. And it would keep going. So it's going to keep going that direction, and it's also going to keep going this direction. Okay, so if you look, it looks really similar to our graph right here. This would be the function of sine or cosine with some shifts involved. And so we'll talk about transformations later, and we'll take them slowly. But anytime you have a function that models this curve, we're either talking about the sine function or the cosine function. So let's talk about the key values. This is the parent, okay? Every function has a parent before you make any shifts, okay? So the domain, remember that's our x values. If I look at the x values, it's going to keep going to the right, it's going to keep going to the left, so the domain is all real numbers. The range is the highest and the lowest the function will travel. For the parent function, notice how the maximum value is 1 and the minimum value is negative 1. So the range is y is between 1 and negative 1. The period is the amount of time it takes to complete one full cycle. So we started at 0 pi and we went to 2 pi. So 2 pi is the period. The amplitude, remember that's the distance between the midline and the midline and the maximum or the minimum. So you can look at it two ways. You can either add the max and the min and divide by 2, or you could just recognize that it's the line that's halfway in between. So in this case, the line that's halfway in between is the x-axis. So y equals 0 is my midline. My midline is y equals 0. So I should write that in for midline. And then the amplitude is the distance. Well, how much up and how much down do I go from that midline? I go up 1 unit and down 1 unit. So a equals 1. So this is my parent function of sine. One thing that we can maybe use as a trick, sine always starts at the origin. So origin, then it goes to a maximum, then it goes back to the origin, then it goes to a minimum, and then it goes back to the origin. This is the cycle of sine. Oops, can't spell. Sine cycle. Okay, so this is origin, then max, then origin, then min, and then origin. And actually, I shouldn't say origin. Maybe I should say x-axis. So we go x, x, x. It starts at the origin, and then it's the x-axis. Okay, for these ones as well. Okay, so we'll talk about that a little bit more because I'm going to refer to that a lot. So then the cosine function is going to be very similar, except for cosine has to do with the x-coordinate. So I'm going to go back to my unit circle, go 1 unit in every direction. Remember, the cosine of theta is equal to the x-coordinate. So if this is 0, then I have the ordered pair 1, 0. And this is pi over 2, and I have the ordered pair of 0, 1, and I have pi and the ordered pair of -1, 0, and then 3 pi over 2 in the ordered pair of 0, -1. Let's draw in my circle. I missed a little bit, but you get the idea. So we are focused on the x values. Well, if I started an angle of 0 radians, what is the x value, or the x value at 0 radians? Well, it's 1. If I go to pi over 2 radians, what's the x value? 0. If I go to pi radians, what's the x value? -1. 3 pi over 2 radians, I'm back at an x value of 0. And if I go to 2 pi, I'm back to where I started, which means my period is 2 pi again, because I'm back to where I started. Ooh, turn all that off. I'm back at 1. Okay, so I'm going to go ahead and I'm going to put in starting to 2 pi, and here's 0. Remember, halfway is 1 pi. Half of that is pi over 2. And halfway between pi is 3 pi over 2. All right, so then what we're going to do is we're going to plot. So at 0, I'm at 1 on my y value. So I'm going to put a point. At pi over 2, I'm at 0. At pi, I'm at -1. So here's -1. I'm going to turn all that off. There we go. At 3 pi over 2, I'm at 0 again. And then at 2 pi, I am back at 1. Come on, turn it all off. So then if I connect, this is going to look a little bit different. But if we were to continue, my next move would be go back down. And if I were going to go the other direction, I'm going to go back down. So you can see that the domain is all real numbers again, because my x values are going to continue. My range, I'm still traveling for the y values between -1 and +1. My amplitude from the midline, so the midline again is that midway point between the max and the min. The midline is still y equals 0. And I only go up 1 unit or down 1 unit from the midline, so then my amplitude is a equals 1. So sine and cosine are very similar in their parent functions. They both have this kind of go down and then up and then down and then up, this periodic pattern. And so what we're going to do throughout the unit is take a look at these functions and then shift them and transform them just like we did all of our other functions. Okay? All right.